The question says write the structure of the major organic product in each of the following chemical reactions. So you can see there are 8 chemical reactions are given here and we have to write the product one by one. Let's take a first chemical reaction. We have a CH3, CH2, CH2 and Cl is there. Next we have NaI. Pay attention carefully. You can see this is halide and this is also halide. Means halogen exchange reaction. This reaction is known as Finkelstein reaction. And here we have acetone. Acetone is acting as a solvent. Heating is done. In this case, always keep in mind this halide should be more electronegative. Halide attached to the alkyl group should be more electronegative, and this halide should be less electronegative. Then halogen exchange reaction is possible. Otherwise, halogen exchange does not take place. Okay, so in this reaction what will happen, this iodine will come in place of Cl and Cl will go in place of iodine. So NaCl is removed from here and we get CH3CH2CH2 and I is there. Reaction is completed. Halogen exchange reaction. Finkelstein, remember, this is Finkelstein reaction in which this halide should be more electronegative and this halide should be less electronegative. Then halogen exchange reaction will occur. Okay, move on to the next chemical reaction. We have the second one. In this case you can see tertiary alkyl halide is there. Let me write the structure. This is CH3 is there. This is also CH3 and then we have CH3 and Br is there. It says KOH and ethanol means alcoholic. KOH is given here. Here we have KOH and this is what alcoholic. We can mention C2H5OH is there. Okay, now pay attention very carefully. If we have a KOH and then ethanol, so it will form C2H5 and it is O and K is there. You can break it from here. This portion is acting as a base. Strong base is there. Okay. And a strong base will be causing elimination reaction. Hydrogen halide means acid is eliminated, dehydrohalogenation. Okay, from this substance hydrogen halide is removed in the presence of strong base because it is generating strong base. We have C2H5 and it is O minus is there. So it will be targeting hydrogen halide which is acidic in nature. Acid base reaction will be taking place. Hence this reagent causes elimination. This reagent causes elimination of what? Hydrogen halide, because that is acidic in nature and this is strong base. It targets acid present in this alkyl halide. Okay, pay attention carefully. How we complete this chemical reaction? Always keep in mind from alpha carbon we remove halogen and halogen we have Br. So alpha carbon we remove Br and from beta carbon we remove hydrogen. This is how we are going to complete the reaction. Now you can see this is alpha carbon. To this alpha carbon halogen is attached. This is beta carbon. With respect to this alpha carbon beta. And all these beta carbon are same. Hence only one product is possible. Let's say I consider this is a beta carbon. Anyway, here we have beta carbon. This is also beta carbon. This is also beta carbon. Okay. So in this case, what do we do exactly? I remove this portion. Okay. I can write it like this also H. Okay. From alpha carbon remove Br. From beta carbon remove hydrogen. So we can remove this portion. And the place we remove HBr, the place we remove hydrogen halide, that place you have to put one pi bond to satisfy the valency of this carbon. Okay, this carbon is there and this carbon is there. Here you have to introduce one pi bond once you remove this hydrogen bromide. So HBr is removed from here. It is a strong acid and this is a strong base. They will neutralize each other. Okay, double bond will introduce. We got CH3, the C double bond CH2 and we have CH3 there. This is the final product. Okay, you can see elimination reaction. Very interesting reaction is there. You can see KOH and C2H5 they are forming a strong base and a strong base causes elimination reaction, eliminating hydrogen halide. Okay, so in this case we are getting, this is the product we are getting. This is the product we have. Okay, now move on to the next reaction. Third chemical reaction is there. Third chemical reaction we have CH3 and CH2Br. Always draw the structure, it will be easier to complete the reaction. Here we have the Br. Next we have CH2 and this is CH3 that. Now pay attention carefully. You can see this is NaOH and this is water is there. Means aqueous sodium hydroxide is there. Whether we have KOH aqueous or we have NaOH aqueous is there. NaOH aqueous. Okay. These two regions will be causing substitution reaction. Easily they can keep in mind if we have KOH and aqueous is there. So easily it can liberate OH minus ion is there. OH minus ion. Now one thing you can say potassium hydroxide. Okay, acting is a strong base. Obviously it is a strong base. Why it does not cause elimination reaction? Problem with this, you can see aqueous medium is there. As soon as OH minus ion is liberated, so you can see OH minus ion will be surrounded by water molecule. Easily it gets hydrated. When it gets hydrated, its basic character goes down. Okay, basic character goes down. It is getting hydrated and hence its basic character is going down. That's why it does not act as a base. It acts as a nucleophile, a strong nucleophile. Okay, substitution. So in nucleophilic substitution reaction, what happens exactly? A strong nucleophile will kick weak nucleophile and will occupy the weak nucleophile space. Okay, in this case what will happen? In general, if you want to carry out the rearrangement, anyway, if you want to remove Br, a strong nucleophile is there, so it will be following SN2 chemical reaction. We do not consider rearrangement. Okay, if SN1 chemical reaction is there, rearrangement is possible. Anyway, in this case, you can see if I remove Br, what kind of carbocation we are getting? This is having negative charge, it is having positive charge. This is a secondary carbocation. Okay. Rearrangement is not possible because we have only secondary carbocation. This is also secondary carbocation. This is primary. This is primary. From secondary to primary, we cannot move. We cannot carry out the rearrangement. Okay. So you can see this is secondary carbocation. So what will happen? Br is removed. Br. From here we are getting what? OH minus ion is there. OH minus ion. We have OH minus ion is there. Okay. So Br will be removed and OH minus ion will occupy the space. Okay, so what will happen? This portion will come here, it will be removed from here. So we get CH3, it is CH, it is OH is there, this is CH2 and this is CH3 there. Reaction is completed. Substitution reaction. Weak nucleophile is displaced by strong nucleophile. Reaction completed. Keep in mind, KOH you should not get misguided by KOH. No, it is a strong base and then it can cause elimination reaction. Keep in mind KOH aqueous causes substitution reaction and KOH alcoholic causes elimination reaction. Okay. Next chemical reaction. Next we have fourth one. In this case we have CH3, CH2 and it is Br is there. Okay. We have KCN and you can see we have aqueous and ethanol is there, ethanol. Okay, it will also cause nucleophilic substitution reaction. From here we can get a strong nucleophile. This is what Cn minus ion is there, Cn minus ion. Okay, it will kick weak nucleophile. Substitution reaction will be taking place. We get CH3, it is CH2. This is what we got, Cn is there. Okay, propane nitrile, ethyl cyanide we can say. Okay, KBr will be eliminated. You can mention KBr here. Okay, KBr. Next chemical reaction. We have the fifth one. Next is what? C6H5. Let me draw the structure, that is better. Okay, benzene ring is there, benzene ring, and it is O and Na is there. It is reacting with C2H5 and it is Cl is there, C2H5Cl. This is alkyl halide and this is sodium phenoxide. It is a name reaction, Williamson synthesis reaction. This reaction is used to produce ether. Okay, in this case what will happen? Na and Cl will be eliminated. Here we remove NaCl. Okay, and how we remove mechanism is there. Via mechanism we can understand very easily. Okay, logically we can see we are not talking about the mechanism, we have to form the product. So NaCl is removed from here and this O minus and this C having positive charge will combine together. This is what we have, benzene ring O and this is C2H5 is there. Ether formation is there. Okay, keep in mind this is an example of Williamson synthesis reaction and in this reaction ether formation takes place. Okay, move on to the next chemical reaction. We have the sixth one. In this case, we have, you can see CH3, very interesting chemical reaction, CH3CH2CH2 and it is OH is there, and we have SOCl2 is there. This is halogenating agent, halogenating, okay, it halogenates alcohol, OH group is replaced by Cl, okay. Halogenating agents, we have PCl3, PCl5 and SOCl2 are there, okay, these are the halogenating agent. But out of these three, SOCl2 is considered as a better halogenating agent. Better halogenating agent. Why? Because whatever the byproducts are found in this chemical reaction, they are gases, and these gases automatically escape. So we get only final product. Okay. In this case, you can see OH is there, and OH will be replaced by Cl. You can see if you look at the structure here, this is SOO and this is Cl and this is Cl is there. Break it from here. One Cl will come occupy the space of OH. Okay, halogenated CH3, this is CH2 and this is Cl is there. Plus, now here we have one oxygen is there. This oxygen and this portion, to support the entropy, SO and O will combine together forming gas. SO2 gas is there. SO2 gas escaped. Next, one hydrogen is there and this is one Cl is there. Hydrogen halide, hydrogen chloride is there. This is also a gas escaped. Okay, this is how we can complete the reaction. So you can see these are the two bioproducts and they escape from the chemical reaction. So main product is what? This is what we get, ethyl chloride. So that's why it is considered as a better halogenating agent out of those three. Move on to the next one. We have a seventh one. In this case, we have alkene CH3CH2 and it is CH double bond CH2 is there reacting with HBr, and peroxide effect is there. Peroxide means anti-Marconi-Cow rule is there. Anti-Marconi-Cow rule. It means that if I generate anion will go to the carbon having more number of hydrogen. Focus on the double bonded system. You should not focus this side. No, it is having more number of hydrogen than Br minus and will attach here. It is not a part of double bonded system. You can see these two carbon are part of double bonded system. So you should focus on these carbon. Okay, you should focus on only on these carbon when we are attaching Br minus anion. Okay, so according to anti-Marconi-Cow rule, anion will attach to the carbon which has more number of hydrogen in a double bonded system. You can see this this carbon is having more number of hydrogen. This carbon has more number of hydrogen, hence Br minus ion will attach here. Okay, and then hydrogen will go to this carbon. Okay, focus on the double bonded system. This portion will remain same as it is. We have CH3CH2 CH, one hydrogen converted into CH2, and keep in mind one bond is broken. Okay, when carbon is forming new bond, then it has to break old bond. And we get CH2, it is Br is there. And butyl bromide is there. And butyl bromide. Reaction is completed. Okay. In general, in anti-Marconi-Cow rule, we get primary halide, and in Marconi-Cow rule we can get secondary as well as tertiary also, depends. Okay, move on to the last chemical reaction. We have eighth one. Again we have CH3, it is CH, okay, double bond, it is C. We have CH3 and it is CH3 there. Draw the structure. We have HBr, very interesting question, but in this case we do not have peroxide effect. No peroxide effect, no H2O2 effect is there, no peroxide effect. So keep in mind anti-Marconi-Cow rule acts only in the presence of peroxide effect. Okay, acts under in case of HBr when H2O2 is there. Okay, but in this case we do not have peroxide, H2O2 is not there. So that's why this reaction will be taking place according to M rule only, Marconi-Cow rule. It will be taking place according to Marconi-Cow rule. Okay, according to Marconi-Cow rule. And one more interesting part. If I take alkene is there, let's say we have CH3, it is CH double bond, CH, and then we have CH2 is there, and in this case, let's say we have HCl, and even if we are putting H2O2 is there. So this reaction will not be taking place according to anti-Marconi-Cow rule. You cannot say hydrogen peroxide is there. hydrogen peroxide is there, but this reaction will be taking place according to Marconi-Cow rule only. According to Marconi-Cow rule, keep in mind anti-Marconi-Cow rule is applicable only in case of HBr when hydrogen peroxide is there. With remaining hydrogen halide, even if hydrogen peroxide is there, we complete the reaction based on Marconi-Cow rule. Okay, be very careful. Okay. Now, Marconi-Cow rule, so we have anion. According to Marconi-Cow rule, anion will go to the carbon having less number of hydrogen in a double bonded system. This is a double bonded system. Okay, here we have double bonded system. This carbon has only one hydrogen and this carbon does not have any hydrogen. So comparatively, this carbon has no hydrogen, this carbon has hydrogen. Okay, so I can say this carbon has no hydrogen, and in this case if we compare, so it is having this carbon is having more number of hydrogen in comparison to this one. This is the conclusion we can have. Okay, the Br minus sign will attach to this carbon, break this bond, and hydrogen will go to this carbon. So the product we are getting, this is what CH3, then we get CH2 and then C, and we have CH3, and this is CH3 there, and this is what we get, Br is there. This is the product we get. If you like this video, please share and subscribe to the channel.